you have to select and apply mathematical problem solving techniques to discover complex patterns. You have to describe patterns as relationships or general rules, and you have to verify validity of these general rules. Now, in this sense, I think it's a bit tenuous, but it can go quite well with what we're doing, right? So, if we look at select and apply mathematical problem solving techniques, what in this context is that going to be? Do you think? What are the mathematical problem solving techniques you're going to have to use and apply?
Actually, never mind. Doesn't apply to our slope equation.
That could be part of it, yeah. So you are going to apply your knowledge of how to do a line of best fit, yeah. So you gradient, intercept, all of that kind of stuff. Yeah. Why would it cover complex patterns? Well, your data is going to be all over the place potentially, right? Therefore, for you to come up with the correct line of best fit to represent that data, it might be quite a complex calculation for you. What do you think then, to select and apply the problem solving set, what do you think is not necessarily going to just get you a good mark in terms of finding that equation? Yeah. Yeah, but that's what I want you to do. In doing that, what is a good way and what's a bad way? Samantha. Well, how can I not show my work and still come up with the equation? It is possible, but I'm not being sarcastic. How can I not show my work but still get the equation?
You did it online. You got.
Yeah.
You didn't install it. You didn't work it out.
If you just get your computer to find you the equation, that's not gonna. There's no problem solving skills there at all. There, okay. You've got the computer to do it for you. All right. What? So what I would say is you can use the computer to tell you what it should be, but I was talking to you guys on that feedback, I would expect if you want to apply some problem solving techniques, for you to do it by hand yourself. Yeah. It doesn't mean that the graph itself has to be drawn by hand. You could plot it on the computer, absolutely no problem. Print it out, and then find the gradient, intercepts, and that kind of stuff. Yeah. What I mean is, don't just get the computer to do it, and that's unless you want a lower grade. Okay. We've kind of already covered this. Describe patterns as a relationship or general rule. What would one of those? What would a general rule for describing a pattern be in this case?
The independent variable has a impact.
That's not what I'm thinking. I'm kind of thinking of an end point. How are you going to describe the pattern as a general rule in this case?
Like concluding where someone's doing like foot length and height, like as the foot length increases, the height.
Okay, so what have you done before that? So that would be part of it. You're describing correlation correctly, right? Is it a positive? Is it strong? Is it linear? Is that kind of stuff. But I just said we've just been talking about it. What is a general rule for the relationship?
The line of best fit.
The equation for the line of best fit. Yeah? So actually, a correct equation is a general rule for your data. And how can it not be consistent with your findings? Well, this is basically if you make a mistake in calculating the equation, right? If the equation is correct, then it's consistent with your findings. If the equation doesn't fit the line, it's not consistent with your findings. All right? So that's where I'm kind of squeezing this criterion B in. I'm considering that the equation, the line of best fit, and your discussion on correlation, strength, linear, whatever, form, and something else. What is also a good generalization of what you see on the page in front of you? So we've got the vocabulary for correlation, we've got an equation of a line of best fit, and we've got mean point is part of the equation. There is something that's not part of the equation that you can use to help you describe the correlation. Pearson's correlation coefficient. Okay? That's something you can just use your computer for. But you can write that down and say, this is what this tells me. That also enables you to describe the pattern in a general form. Yeah? Generally, I know the correlation is this. Pearson's correlation verifies that. Okay? Jackson, did you have that? Okay. How can you properly verify and validate any things that you're talking about? So those people, go on.
You could plot a point and put it back into your equation.
Yeah, good. I was just asking for those people that have feedback. I don't think anyone in the first group actually used their equation at all. All right. I'm pretty sure one group's equation was wrong. It didn't match the data at all. All right.
Wait, what did Matthew say again?
So annoying, isn't it, Matthew, when people don't listen to you? He said you basically, to verify that you're correct, okay, verify your equation, you put one of the points that you already know, right? Or you choose a value and you want to see that it is reasonable, yeah? So we're doing height and stride length. No, you're still not allowed to do that again. If I know if I put in a height, I can use my equation to predict what their stride length would be. Yeah. Now, potentially, if I was doing that, I could go, well, I'm not going to use my own data for myself in this data. And then when I come up with it, I'm going to predict my own stride length. I'm going to put my height into my equation. I'm then going to measure my stride length and compare those two things. And if it comes out as a reasonable answer, there is some verification that I think I've got a reasonable model. Okay, there's a good word for you to write down. That equation is a model, but we have talked about that before. So another good word to write down. Write that down. The equation is a model, right? It's a mathematical model. Yes.
So, sorry,
I would suggest that you actually draw your line of best fits by hand. Okay. Your other option, if you prefer, you can use GeoGebra and do what we did, where we constructed it, right? But I would, do you remember how we kind of put a point down and then we drew a line between that and then we rotated the point? Do you remember doing that? Yeah. All right. If you don't remember, don't worry about it. Right? Just print out and draw it by hand, but it must go through the mean point. But if you want to, if you know how and you're happy to use GeoGebra, you can use GeoGebra to do the same thing. What I'm basically saying to you is don't just click do it for me. Yeah. Now what you can do is after you've done your own, you can click do it for me and compare. And if yours is completely off, it's worth checking. Yeah. What I do find a little bit frustrating is when someone has done something and it's quite clearly wrong and they must have seen it was wrong and they do nothing about it. So you can do it by hand, or if you're smart, do it first on the computer, write that down on a little post-it note, then do yours and see whether you get a similar answer. You might not get the same answer, but it should be reasonable, yeah? Remember we went through that in class when I got you to do it by hand and I got you to do it for homework, didn't I? We all had different ones, right? Because you all did different lines of bit by eye. But then we put it into the computer and went, who was the closest? Remember we did that? because I'll see your calculations for the rise over run. I'll see the calculation for how you worked out the plus b bit on the ends. Remember, once we know the gradient, we've got a point we can use. Did we use the mean point or something? You put that as the x and the y in. Quite a long time ago we did all this, so this is a real challenging piece of work, more because it takes you back in time, right? Okay. What about the validity thing? What can we do to check the validity of our general rule?
But we could do interpolation.
Yeah. You could check to see whether your rule is applicable beyond certain points, right? Now that bit goes hand in hand with criterion D as well. So this is how I think we can get a decent criterion B out of it. You are using mathematical strategies to come up with, what did I put as the first title? Drawing conclusions from analysis of data. So you are looking at, can you spot any patterns in the data that you collect? All right. Any questions on criteria B, or can I move on? Move on? Okay. Oh, by the way, this just shows you for each strand separately, like if you want the, I think I've already printed these out for you in the past, but you can do your own, but I can print off or put it on Teams. I can put these on Teams like, rather than print them all. You can see how in one particular strand, how you can go up the levels. All right. So you can see that to get a 7 and 8, you have to select and apply mathematical problem solving techniques to discover complex patterns. All right. So if your stuff is too basic, you lower down the levels. Okay. All right. The easy one then. Communication. Consistently use appropriate mathematical language. Would anyone that's got some feedback like to give me an example of what is not decent mathematical language?
Using the word
Decent.
decent.
Yeah.
and essential.
Decent and essential, yeah. The correlation was decent. Yeah?
I think it was we used word accurate wrong.
Yeah.
And accuracy is more like how specific your measurements and
Yeah.
data is. And it didn't work when we
Yeah. Samantha, what were you going to say? Say the same thing. Yeah, so just, you know the correct mathematical language for discussing correlation. It is correlation. It is strong, moderate, weak. We have a line of best fit. We have, Pearson's correlation coefficient. They're all good things when you are discussing relationships and that kind of stuff. I'm looking for the appropriate mathematical language. If you don't know the appropriate mathematical language, get the textbook out on the chapter that we were on and use the words that are in it. Yeah. And think carefully whether what you said. So, for instance, the decent comment. I think if you sit back and go, what is a decent correlation? You're basically saying it's a good correlation. Well, what is a good correlation? Well, good kind of means it's favourable to you, yeah? Oh, that was a good result, favourable to what I want. But correlation is just, it is or it isn't, yeah? But
So then, how would you think?
I think what Matthew was meaning instead of decent, he meant to say it's strong, it's positive, it's linear or non-linear, yeah? Those are the words we should use. It's moderate, it's weak, there's no correlation, yeah? That kind of stuff. Consistently use appropriate forms of mathematical representation to present information correctly. Graphs, what do graphs need to be? Like
Labeled and have a title, so like
labeled, title,
x-axis and
X-axis, Y-axis need to be labelled.
Should be extra space.
Yeah, the zooming in thing, have the points that you are plotting, fill that page, right? Fill your graph, don't have them in a tiny little dot in the middle, I saw that a couple of times. Okay. Define your variables. I actually think that was a relatively good thing you guys were doing. You did say on the whole, when you had y equals mx plus c, well, we shouldn't end up with y equals mx plus c, we should have h equals ms plus c. H for y, because h is height, s for x, because s is stride length. Okay, so we shouldn't be leaving it as y equals mx plus c, we should actually have h and s in there, potentially. Or, if you're happy with x and y, somewhere you must define x is stride length. What, that's a way to get over it, if you're happy with that. Okay. Communicate through lines of reasoning that are clear, coherent, and complete. Well, that's about writing your conclusions. All right. I will give you a tip here, guys. Communicate through lines of reasoning that are clear and coherent. So, coherent, part of that is don't waffle. You know what I mean by that? All right. I remember a teacher of mine when I was sort of younger than you, and it's going to date me now, but computers were basically becoming the norm to write your work instead of handwriting. And one thing that my teacher said, oh, it's clear, you know, when someone does it on a computer, basically you sit and type, and because it's so easy to make corrections or copy and paste and move things around, basically there's no fear of overdoing stuff. So you just type, you go, oh, did I say, oh, I just typed that again. Oh, what did I say? Oh, I just typed it again. All right, so you end up having 3 forms of the same thing being written. All right, and then you go, oh, I just copy and paste, I'll just move that, that makes it, right? When you have to write by hand, think about it an awful lot more. All right, especially when you've got a father like mine, who if I made one mistake would tell me to rewrite the whole page again. All right, so I was very careful. All right, that I didn't make any mistakes or say something I didn't want to. You should go back to that. Now, a good way to do that is if you think you are clear and coherent, have someone else read it. Because it's you should think about it. When you are looking at your own work, it's very difficult to spot your own mistakes, because when you're reading what you wrote, you're not reading the words. You're thinking about what you intended to say, and when you're reading, you're actually just thinking about this is what I intended, so that's what is on the page. And quite often it's not. All right. Effectively use different forms of relevant mathematical representation. That's just kind of graphs, tables. I did like in the guys one yesterday having arrows picking out particular points of interest, that kind of stuff.
Hey, what about the arrows?
Well, they were looking, they talked about a potential outlier in their data, and they kind of went, this is the one we're talking about, yeah? So they had their graph. So coming on to this, present work that's consistently organised and using a logical structure. What I don't want is a graph and then 2 pages of essay. I hate it. I'm not an English teacher, I'm not a history teacher. I don't like essays, hate them, alright? I like pictures, alright? So I like a bit of writing, here's a picture that shows me what. Now, also what I don't want is a description of how I find the equation of a line of best fit. First of all, I take a point, and then I find another point that might be on the line, and then what I do is I look at the difference between the x-coordinates and the y-coordinates, and then I subtract those numbers, and then what I do is I take that number and I divide it by the other one. Then to find that I don't need any of that, I just need, here's the equation of the line of best fit. You could show the calculations, but I don't need a running commentary of what you do. It just annoys me, all right? Because that is filler. That's if I put enough words on a page, Mr. Potts is going to be happy with my work. No, that's filler. That's easy, not having to think about it. There's no analysis of the data. Nothing. Matthew.
So you want us, for the equation, you want us to show it with numbers and not with words?
Yeah, so I will see, like here is the equation, you can write here is the equation of the line of best fit. You know, you can even show underneath of it, you say, here is the calculations, and you can show the calculations, and I can look through the calculations and go, yeah, that's all right, tick, tick, tick. Okay, I don't want a blow by blow, you know, I can see a picture of some numbers like I would do in your textbook and, or your exercise book, and I can tick. If it's a whole paragraph or four, I've got to read through that, and then I'm trying to, I'd rather just see it visualized, yeah? Like you would do if you were working out a problem in your exercise book. Just think of it like that, right? You're showing the same thing. And like I said, no one graph, a big chunk of writing. Okay? Maybe you want to put a table out and you say, sort of, for the table, next to the table, you say, I'm going to define my variables. So x this, y is this, y is 1x, y is 1, what, you know, why have I chosen the independent variable, why have I chosen the dependent? All right, next to that, then you can say, right, this now goes into my graph. You can see certain, you know, maybe even select a small little section of your graph if you want to talk about outliers and stuff. So it's not, yeah, that's really good, yeah. Yeah, you could just sort of select small sections if you like to add to your. All right. By the way, just in case you're wondering why I'm making a thing of this, in DP, all right, you have to write something called an IA, an internal assessment, and you have to do it for every one of your subjects. And it's basically a self-guided exploration of something. In maths, it's a self-guided exploration of something, and you have to produce a report on it. And if we don't practice these skills, then they're normally quite poor. All right, and you'll be doing your personal project stuff as well, right? So these kind of skills like that. All right, any questions on communication? Any advice from the people that got feedback about what they didn't do, could be added? No? Did anyone do picture lots of writing in their piece of work? Sammy remembers, yeah, Sammy did that. Guys did that, yeah? Bit. Ben's, how about your groups? What was the problem with yours? Yeah, no title, graph wasn't labelled, it was just a bit plonked at the top of a page, no thought of how it was presented in any way, yeah. So you're going to improve on that. X and Y on the graph, didn't have that, yeah. Okay. Again, if you can't figure out how to label your axes on the computer, I said this before, what do?
Do it on your board.
Hey?
Draw it on your board.
Well, print it out and write it on by hand, yeah. It's absolutely no problem.
Or like along the line of best fit, can we like draw it digital program?
Whatever you've got to put in the labels, do it. If you can't use a computer to do it, print it out and draw it on by hand. There's nothing wrong with that. Okay? All right. And finally, criterion D. So the big ones, can I just ask where? Well, no one got anywhere near this level. Criterion D. Selecting adequate. I'll go to 7 and 8. Identify all the relevant elements of the authentic real life situation. So that's simple as if I think you've missed out something very important in the piece of work that you're doing, you haven't selected all the relevant elements. So sit down and think, what could be affecting my results? Yeah. Selecting adequate mathematical strategy. Well, that one's kind of simple. That's kind of easy. The strategy you are going to use is gap plot, equation, that kind of. All right. Correct solution. What can make it incorrect again? So your equation for your line could just be completely wrong. You could get your independent and dependent variables the wrong way round. You could say this is a positive correlation when it's actually a negative correlation.
Wait, where's
So when it's positive, if something changes, it causes the same change in the other one. So if it goes up, the other one goes up. If it goes down, it goes down. All right, so that's a positive correlation. Yeah, negative is if one thing goes up, it causes the other one to go down, or the opposite. Yeah. All right. Now here's where we really went wrong. Degree of accuracy. So over to you. What does it mean, Matthew?
if you're set,
Yeah.
if you're measuring like height,
Yeah, if you're doing something that involves measuring, why did you choose centimeters? Why did you choose feet and inches? Yeah. Why didn't you choose millimeters? Okay. What do you think the difference between explain and justify is here?
Explain is like walk you through it, but justify is proving that it's correct.
So explaining the degree of accuracy is I did centimeters rather than inches. Justifying it is I did centimeters rather than inches because. Yeah. If all you do is discuss it, alright, I am going to put this on Teams, right? If you're just writing this out, that's a bit of a waste of time. Alright? When I said take notes, I kind of meant like the stuff we're talking about, the ideas that go. Right. Discuss the degree of accuracy of the problem. That's just basically saying, when I'm measuring, I had to make sure that I measured using correct things, yeah? Correct units. That's a discussion. That's basically what people tend to do when they just, a little nod to the fact that Mr. Fox told me I had to talk about accuracy and it had something to do with units of measurement. So I'm going to say that I know what he was talking about, but I don't really get it at all. All right. So that will put you in the 3 and 4 bracket. Yeah. So things like when we were measuring, people were messing around and the ruler got bent. You know, that was in someone's work. That's discussing that you know that could affect the accuracy of your measurements, but you didn't really explain what the effect was, didn't justify why that might have actually been a problem. And then, does your solution make sense? How can we get that in? You have a solution. Your solution is actually, your equation is only part of your solution.
does the overall conclusion make sense? So if a taller person had a bigger stride length, does that make sense? Or if a shorter person had a bigger stride length than the taller person, that makes sense.
Okay, so as Matthew is alluding to, you kind of should start with a problem that you are going to answer a question about. So that group that I spoke to yesterday definitely had they started with, we're looking at whether taller people have longer stride. Your solution should be a conclusion on that, all right, with evidence. The evidence being, here's an equation, here's a correlation coefficient, all of this is supposed to give evidence to your final solution. The solution being, yes, taller people generally have a longer stride. Does that make sense? Well, can I use my equation always? Is there any limit to my equation? Was there any limit to an equation on height and stride length? Yeah, I like that one. That was a good they put in theirs. they looked at, well, if you kind of go too low, someone that's 3 feet tall would have a stride, they would be walking backwards. So I don't know how you want to interpret that, but it doesn't. Now, whether it makes sense doesn't mean the whole thing makes sense or not. You could discuss whether some parts of it make sense. It doesn't make sense to use my equation for this height, or even would it make sense to work out someone's stride length if they're 10 foot tall? People don't tend to grow to 10 feet tall, so therefore my equation doesn't go forever, right? Also, you could also do a little bit of research if you want a really good grade, and to say, well, after about the 8 foot, actually people tend to struggle to even walk if they're too, because normally that comes with health problems and they've got a walking stick and their body can't actually cope with that immense height and size. So stride length can reduce. All right. Also, do you remember we talked about this one thing called causality, causation? What's that? What is causation? Ben?
I was
In this context, what would that be?
how is real.
You're very close. You haven't quite got to the point I'm thinking of. Do you not remember it? You've forgotten the causation thing? It is a cause and effect thing, but it could look like there is a relationship, but is there actually a direct relationship between those two things? Or is there something else? Does that affect something else that then affects this? Is it a direct relationship or is it not? All right. I think I gave you ideas, like you can find them online on jokey websites and things, that there looks like a direct relationship or a positive correlation between Nicolas Cage movies being released in a year and the people committing suicide by drowning. Okay? I think it is like generally something along those lines. There's a lot out there, obviously, there is no connection between those two things, but if you just plot the number of deaths by drowning by movies being released, it could be a positive correlation. So you could come up with a conclusion of, be careful if Nicolas Cage is releasing some movies, we need to up them, but it's not the case at all. So that also, for those people that want the top ends, you can look at, well, am I happy that one thing does actually cause the other? Is that a sensible thing to be saying? Does an increase in height increase stride length? Makes sense for particular reasons which you could discuss. Right. So, those that had feedback, anything to give for us to consider? So there was the, yeah. Yeah, I do like that. I don't, basically, one thing I remember saying a couple of years ago to a group, I don't want your opinion. That's a good thing to write down, actually. I don't want your opinion. I want a conclusion based on evidence. If the evidence doesn't back up your statement, basically you're saying, you're just forgetting your data collection completely. So I do not care what your opinion is. All right. You can say, I think taller people have a longer stride length. Fine. Where's your evidence to back that statement up? If your evidence doesn't say that, I will mark you down straight away. Go, well, your graph doesn't agree with you. All right. So you've just given me your opinion. If you had to stand up in front of the, the President of the United States and argue something, and you went, I think this, and you went, right, where's your evidence? And you went, here it is, and you went, that doesn't say that, get out of my room. Yeah. Think of it like that. I can be the President of the United States when you hand this in. All right. Accuracy. Remember, don't misuse the word accuracy. Something is more accurate if the measurement is smaller. If I measure someone's height to the nearest inch or to the nearest centimetre, centimetres are more accurate because they're smaller. Millimetres are even smaller. But is that justified to use millimetres? That kind of thing. Alright, any other questions on those? Anything to offer that I've forgotten to say that we did talk about? Yeah? I don't want you to use a word instead of accuracy. I want you to use the word accuracy in the right place. Actually, the one word we did say, what was it? Reliability. Remember we said our conclusions are reliable. Now that comes down to, did I collect my data appropriately? If my data was done, some people had shoes on, some people didn't, my conclusions are not reliable. Yeah? You don't always tell the truth. What do I think if you come in and tell me that you didn't do your homework because blah blah blah? Yeah. Your statement is not reliable based on the evidence that I have that contradicts it. Yeah. All right. Now I've talked far too much. It's already 9:50. All right. So I did want to give you some time to think about what your two variables are going to be, and have a discussion with each other. So I'll tell you what, I'll stop recording.